So f of 0, which one would you plug it into?
For the second one.
Second one, because that's when x equals 0, so f of 0 should equal 1. F of 1, you put that into the first one, and we get out 2. F of 2, you put that in the first, and you get 2. To graph, 4, I mean, sorry. To graph it, we make our t-chart. And this first one is for everything except 0. So you're really doing some negatives, some positives, but we need to put in 0 itself. When you plug in 0, since it was not equal to, we're going to do an open. And all we're getting is just a line. So 0, 0 is an open circle. 1, 2, 2, 4, -1, -2, -2, -4. So it looks something like that. The second piece, 1, if x equals 0, the only x value we plug in is 0, and we get out 1. So 0, 1 is a point. Quick check, make sure it passes the vertical line test. That'll catch it if you accidentally put a closed circle instead of an open circle, or if you did 1, 0 instead of 0, 1. We know because it was originally f of x equals, it is a function, so it should pass that vertical line test. So the domain of this, as we go from left to right, what would it be? Range is referring to possible y values, so that would be? Good. We never actually hit 0 because of that open circle. Is this continuous? No. It's not continuous for the entire thing, which is what the question asks, but you could give me intervals where it's continuous. Essentially, it's continuous everywhere except at 0. All right. Any questions there? So now we've looked at f piecewise, and we've covered a case where you have an open circle, so the equal to and not equal to. We looked at inequalities, so we're moving into our last type of function, which is the greatest integer function. This kind of type's a little weird, but it's the double bars around your x. Do you guys remember what a greatest integer function does? Have you ever seen it before, maybe? So a greatest integer says you can only get out integer values. So what are integers? No fractions or decimals, but it could be positive or negative. So like -3, -2, -1, 0, 1, 2, 3. Those are the integers. So those are the only possible y values. So you can only get out integers, and you can't get anything bigger than what you put in. So if I make a t-chart, okay, we're used to just putting in nice numbers. But if I put in -1, the greatest integer of -1, -1 is an integer, so the greatest integer function doesn't change it. You just get -1. If I put in 0, 0 is an integer, so I'm going to get out 0. If I put in 1, 1 is an integer, so I'm going to get out 1. This isn't giving me a very good representation of what this graph actually looks like. So let's kind of look closer. Right. On my graph, I'm going to change this. I'm not going to count by ones here. Give myself a little more space. Okay. When I graph those, we need to put in 0. If we put in 0, we would get out 0. So So 0, 0 is a point. If I put in 0.5, 0.5 is an integer. It falls between what numbers? 0 and 1. Gray's integer function says you can only get out an integer answer, so I have to get either 0 or 1, and you can't get anything bigger than what you put in. So I can't get out something bigger than 0.5, so what am I going to get out? 0 still. So when I put in a half, I'm still getting out 0. If I put in 0.8, 0.8 is between 0 and 1. But you can't get out anything bigger than what you put in, so what am I still getting out? 0. If I put in 0.99, what am I getting out? 0. But when I put in 1, I get out 1. So at 1, this thing jumps up. I'm going to count by. Spread this out a little bit too. Okay, so 1 gives me 1. So I am down here on this bottom step all the way until I get to 1, and then I jump up. But I can't give the closest number to 1, can I? Like, I had 0.99, but you could say, oh, 0.999 or 0.999. So to show that it goes all the way up to 1, we're going to put an open circle down here at 1. So at 1, 0, I have an open circle, and then it jumps up to the next step. If I put in 1.5, what am I going to get out? If I put in 1.9, but when I put in 2, okay, so for this step, I'm going to stay here all the way up until I get to 2, and then at 2, I jump up to the next one. So we put an open circle at 2, 1, closed circle at 2, 2. And then I'm going to stay on this one until we get to 3. And I have an open circle at 3, 2, closed circle at 3, 3. This pattern will continue. Also goes the negative way. So if I were putting in like negative 0.5. Negative 0.5 is between negative 1 and 0. What's the smaller one? Negative 1. So at negative 0.5 we're getting out negative 1. If I put in negative 1, I get negative 1. So we're just following this pattern. We have these steps. They're 1 unit long. Closed circle on the left, open circle on the right. And then it just keeps continuing. That is what's called the greatest integer function. Have you guys seen that one before? No? Okay. She used to hit it in algebra 2, but I didn't know what the new curriculum if she did or not. Let's try graphing elements. Oh, I guess I should answer some questions about it though. Domain. As we go from left to right, what are we getting? What x values do we hit? All of them. We have a lot of breaks in the graph, so is this one continuous? No, each little step is continuous, but in between the steps we always have a break. So my domain negative infinity to positive infinity. Range. What y values are we hitting? The integers. So you could write that a couple ways. Do you guys know the symbol for integers? It's a double barred Z. That means integers. Another way you could list it is to say, okay, we hit -4, -3. So list them out with the dot, dot, dot on each end to show that the pattern continues. So you could do either of those to show me your range. Increasing, decreasing, constant. How would we answer that? Is this graph ever increasing? No. Is it ever decreasing? Is it ever constant? Yeah. Each step is constant. So in between the steps we have a break, but each of those individual steps is a constant function. Alright. Let's try to graph the greatest integer of x plus 2. You guys take a second, see if you can figure out what it would look like. So if you put in 0, inside the greatest integer symbol, it's kind of like parentheses, so we work inside first. So we have 0 plus 2, which is 2. So what's the greatest integer of 2? 2. So 0, 2. What's the point? Okay, we can't only plug in integers on these. So let's do like 0.5, 0.9. So if I put in 0.5, then 0.5 plus 2, so that would give me the greatest integer of 2.5, which is 2. If I put in 0.9, we get the greatest integer of 2.9, which is, when I put in 1, we get the greatest integer of 1 plus 2, which is 3, and the greatest integer of 3 is 3. So when we put in 1, we get out 3. That's the point where it jumps up. So we have an open circle underneath. So we can see, once you get one step, then you can really just use patterns to get the rest. So we see the step that's 1 unit long, closed on the left, open on the right, and we're just going to complete that pattern. My rule for these, I want to see at least 3 steps on anything that you draw. Of course, we can do more. And it just keeps continuing both ways. All right, let's try another one. That seemed a little hard. I'm going to add in one. Let's graph the greatest integer of 2x. All right, so if I wanted to do that, let's start by plugging in something. So if we put in 0, what do we get out?
0.
Mm-hmm. All right. What happens if I put in 0.5? 2 times 0.5 is 1, and the greatest integer of 1 is 1. So 0.5 is already giving me 1, and that turned out to be an integer exactly. So that means I've kind of missed something here. If I put in 0.25, 2 times 0.25 is 0.5. Greatest integer of 0.5? 0. So what's happening on this one is it jumped up sooner. So we saw at 0.5 is when we got the next integer value. So this time, my steps are only half a unit long. So we jump up every half. And of course we can keep continuing that as long as we want. Right, so greatest integer, you're always going to see those stair steps with the open and closed circles. Adding or subtracting things just might change how long the steps are or how high they are. Last couple examples for today. An express mail company charges $20 for a package weighing up to 2 pounds and $2 for each additional pound or fraction of a pound. Let y equals c of x represent the cost to send a package weighing x pounds. Graph y equals c of x for the interval 0 to 6. So I'm asked to graph this from 0 to 6. I'm not writing an equation or anything, just drawing a picture for the scenario. Okay, what is the absolute cheapest my package is going to be? I'm going to count by 2's. You notice my interval, it has a parenthesis on the 0. So what kind of circle will I start with? An open circle. Okay, and then we know the absolute cheapest would be $20. So if it weighs 1/10 of a pound, how much are we paying? $20. If it weighs half a pound, we're still paying $20. If it weighs 1 pound, $20, and we stay there up to 2 pounds. So if it weighs 2 pounds exactly, you pay $20. So what we're going to have is an open circle to start it at 0, 20, and then this first step goes all the way out to 2. And then what happens once you hit 2.1 pounds? What happens to our cost? Goes up to $22. Okay, now if it's exactly 2 pounds, you're still down here at 20, but anything over that, we're jumping up. So we're going to start with an open circle, and that's for each additional pound. So if it weighs exactly 3 pounds, you're still paying just that $2 more. But as soon as it goes over 3 pounds, what do we pay? 24, $2 more. So that would be from 3 to 4, we stay at 24. After it goes over 4, we go to 26. So from 4 to 5 pounds, pay 26. And after 5, it would go up to 28. Okay, so this is kind of a step function. Just the first step is longer than the others. Is that okay? Alright, if I said to graph x equals y squared, is it a function? So, what would I do to draw this? It wasn't one of the functions that we've already graphed. So what would I have to do?
Isn't that just y equals the square root of x?
Plus and minus the square root.
Plus or minus.
Yep, if you added, if you solve for it.
Is this always parallel?
It is. So you can solve for it like that. X equals plus and minus the square root of y. You can make a t-chart for either the original or that. If I'm looking at these points, if I were going to plug them into the original, would it be easier to plug in numbers for x or for y? Normally we put them in for x, but here I would almost say it'd be easier to plug in for y because then you could just square it and get your x value. I wrote this backwards, didn't I? This should say y equals plus or minus the square root of x. And if you're using this equation, then it would be easier to plug things in for x and get your y. So just a difference in how you think about it. Either way, we're going to get the same points on our graph. So if I put in the original, maybe I'm going to put in, okay, if I put in negative 2 squared is negative 1 squared, 0 squared, 1 squared, 2 squared. So we have 4, negative 2, 1, negative 1, 0, 0, 1, 1, and 4, 2. So just like Tyler said, we get a sideways parabola. Is that a function? No, it fails the vertical line test. What is the domain? What's the range? Good. All right. So that is the end of this section. So I gave you guys a handout yesterday, and I'm not adding anything to it. So that is the assignment. And we'll turn that one in tomorrow, so you've got time to work and check that. Do you have that handout for homework?
Pretty sure that's not.
Why don't you go see if you can find that?